Computers operate with numbers, often reduced to binary, while humans work with a variety of characters, sometimes thousands or even tens of thousands, depending on the language. This is where character encoding systems come in. Now, what exactly is a character encoding system? Well, it's just any method for representing text characters as numbers so a computer can process, store, or retrieve them. They're descended from signal, telegraph, and cipher codes used in the 19th century. Just about any method's going to use at least some or all of these properties. The set of characters it can represent, that has to be a finite set, obviously. The code points or representations of that set, something's got to represent that set of characters in the system. You've got some kind of encoding scheme for how that works. You could have a unit size too. It could be fixed or a variable length too. System mapping rules, symbol mapping rules. So what decides what symbol is what? This is different than the encoding scheme. Control codes. So you'll probably need something other than just your letters, numbers, whatever. Maybe something to handle error, synchronization, ordering, what order are things in, extendability, can you add more characters to the system? Transmission medium can also be a big deal. This is meant to go over air, over a wire, distances, that kind of thing. Um, do you actually put it, when you're developing the system, do you try to make it more efficient? That was actually the motive behind some of the systems. And then semantic. Give meaning to the characters or the symbols. Of these, I would say the most important is obviously a set of characters, your code points, your encoding scheme. I mean, you're basically coming up with here's what we want to communicate, here are the thing characters we're going to use to communicate it with, and then this is how we're encoding it. And then symbol mapping rules, what makes you use this versus that. Control codes, you're probably at least going to need some really basic ones. Um, but there were certainly older systems before computers that did have them. Probably need a way to synchronize as well so that two devices understand this is part of this message, this is part of that. That can be done with control codes. And then semantics. I mean, things have to have meaning. The other things may not mean so much um, depending on the system, like, but even something like transmission medium, the length of the wire, the type of the wire, that could matter, but for the purposes of the basic encoding system, it might not. Now, I should just mention kind of a history of code. Well, the second languages were written down. Well, that's a code. You're taking spoken sounds and words and giving them a symbol representation. You can speak a word, and that doesn't mean that it's automatically linked to the word things that you write down, symbols or whatever. So right there, you're already doing a couple of steps. You're encoding something right there. And of course, there were plenty of symbols for how do I translate a message, maybe I wave flags or something across the battlefield. All of this thing sort of happened in the ancient world, and there were ciphers and everything. Now, in the 17th century, visual telegraphy became a thing, more so in Europe than in America because of size differences, but there were semaphore codes. A tower would raise certain flags to mean certain things, letters, whatever. And then come into the 1830s, the invention of Morse code by Samuel Morse for telegraphy over a wire. You encoded characters into dots and dashes. This concept can be also thought of as zeros and ones, but not exactly. You'll still see ham radio operators use this. It's still a hobby to learn Morse code and development to use it. And it represents, depending on the version of the code, as few as 50 characters and as many as about 70. Um, it's not a perfect standard. I'm not even sure how you label the variations. And then you had sort of Baudot standard that came about in the 1870s in France and then eventually in the rest of Europe. This was, and you say something is Baudot, you're not necessarily talking about one thing, you're talking about many different code types under a certain standard. Part of why this was is telegraphy was becoming more mechanical. You actually were seeing electromechanic machines starting to show up that could deliver the code. You enter it on a keypad, or it could retransmit and stuff. You needed something that was more expandable, that allowed for multiplexing, that was multiple signals over a same line. And basically, Godot became the ancestor of just about every other coding system. I'm sure there were others. About 30 years later, Murray code came along as an improvement over Godot, but again, just one of many variations. It specifically was optimized for character frequency, so making sure that teleprinters could operate at a much higher and efficient speed compared to human operators. By the 30s, we had things like Telex, ITA1, um, basically standards for the fact that teleprinters were now a regular part of business and government life, transmitting messages. Whereas a few decades prior, we were still dealing with some hand operators. I mean, hand operators still did exist in certain niche markets. The whole attempt here was to finally come up with some unified standards. Before this, standards maybe were within national boundaries. There were reasons for this, different languages, etc. Eventually, ITA2 came out. By the 40s, it was in full swing. From the 40s and the 60s, if early computers used some kind of transmission standard for characters, it was definitely sort of it was in the Baudot range usually, and it probably was ITA2 based. Because if you were sending stuff to a teleprinter, that was probably the easiest way to do it. Um, by the 50s, IBM started using their own special 6-bit systems. By 63, the first ASCII standard came out, and then 1991, the first Unicode standard came out. Now, here's a little representation of Morse code. It's going to go a little slower than real life would. It'd be faster than that, but just so you can hear it. And it's got all the basic letters A through Z, so technically we could feed it a completely different message here. Send message is its own function out here. Remember, this is dots and dashes. Well, technically the space is between as well. So it did SOS, which is the thing probably most people are familiar with, and then the word help. Oh, it's doing it again. Now I found a Morse translator website. I think, yeah, telegraphsimulator.com. So I just typed in a simple message. It's down here. The slashes indicate basically spaces in between words. Obviously, with a real Morse code, those slashes wouldn't have any real value. So you can go to Morse practice. Just to throw it into here is Murray code, very similar I mean, basically an improved version of Godot is a standard, but not quite ITA 1 or 2, but that's a little bit more difficult to really show. But yeah, here you go. So yeah, hello again. All right, here's a Godot, which is more of an idea than a standard, ITA2. set up to a speaker, which you probably wouldn't actually have. At this point, it's binary code of 5 bits for everything, and then the standard was certainly used with teletype. Well, it was used for teletypewriters, and then extended into the computer age as well. So let's see, what is it going to do? Hello, there you go. Hello. Now, what kind of early computer character encoding was there? Well, IBM had their own list of systems they came out with. BDIC, which was binary coded decimal, interchange code. They used it in the 50s, 6-bit code based on binary coded decimal. It was a good starting place. IBM just continued that trend. Their 1401 mainframe had its own character set. It was also 6-bit code that they used from 59 to 71. I think that was the last year that they sold their 1401 mainframe. Not entirely sure if this character set was used on other mainframes, but there might have been certain compatibility schemes. And then there's IBIC, extended binary code, you get the picture, used by IBM. This was introduced in 63, 64, actually still used to this day on some IBM mainframes. I want to say their PCs and probably their mini computers and such probably use ASCII, have all used ASCII. But yeah, you can see this, and there's also been a few other machines that have used it as well to keep it compatible with IBM. In this day and time, it's extraordinarily easy to obviously convert between encoding systems. Once upon a time, not so much. But there's some other. There were some others, like DEC came out with their own 6-bit system in the 60s and 70s. This was used on the PDB-10, among other computers. Also 6-bit, we went from like 5-bit to 6-bit, and those standards held out for a pretty long time. Eventually, you saw some 7 and 8-bit systems start to show up in the 50s and 60s. I couldn't find exact names, so a lot of these were probably one-offs, experimentals for like one models, if even that. And then ASCII showed up in 63. By somewhere between 77 and 85, it became the dominant standard, but it was, as I said, it was hardly universal. IBM was still using their own standards for their non-PC machines. By the late 2000s, early 2010s, Unicode had basically out-dominated ASCII, although in reality, those two often work side by side, especially with computers for a North American market, actually probably everywhere at that point. Why that's a case, why that's the reason, I'll explain. And then we come to ASCII, which I'm sure a lot of people have heard of. They don't necessarily know what it is. Well, the American Standards Association started to begin a development of a universal character encoding system called ASCII, with the point of that all computers would basically use it. They started work in the early 60s, and then by 63, they released the first standard. It was really slow to be adopted, but through the 60s and then by the 70s, it was pretty widely accepted as a standard. But some people wouldn't even call it completely universal or close to that until like 85. Bob Beamer, by the way, is regarded as the father of ASCII. The original standard uses 7 bits, represents 128 different characters, which is actually pretty good compared to some of the older systems. You got to remember, at this point, a lot of things were still using 5 and 6 bits. Using 7 bits was a whole other animal at that point. Included all the basic letters, upper and lower, although I believe the original standard might have just been upper, and then they extended it not too long after that for lower. For the most part, I mean, you really only needed one letter to represent, but having lower was nice too. Numbers, symbols, and a bunch of special control characters. You're going to need a lot more of these if you're going to be using these between computers and not just teleprinters. As I said, 4 years later, they added lowercase letters. And then there were extended ASCII systems. They added an 8-bit, doubled the number of characters to 256, added graphical symbols, foreign characters, etc. Keep in mind that extended ASCII was never a single standard. It branched off in many different directions. So even if something supported basic ASCII, it didn't mean it supported any of the extended sets. And then there was ISO A859-1, more commonly known as Latin 1, that added a lot of character support for at least Western European languages, think diacriticals in German, etc. Windows, Microsoft made their own, the 1252, but they added more graphical symbols. The IBM PC had code page 437 that was used in IBM PCs that was based off ASCII. And here's a little chart of the 7-bit. It's pretty simple. There's people who literally memorize this, but you've got the name, the decimal, binary, hex. Now the first 32 here, there's just purely control codes. Now, of these 32, maybe 8 of them are actually important to day to day, but there are a lot of things here that just aren't used. There's things for I couldn't even tell you some of these, like end of storage, and there's some device specific codes that devices can decide how to use them. But there's also, carriage return, line feed, things that you would use on a day-to-day basis. Null is important. But then you've got space, and then you've got your symbols, numbers, more symbols, more letters, etc., lowercase, etc., and then eventually you get to delete. And this is Latin 1. I didn't like the charts for it, so I just kind of pasted it up. But yeah, you'll notice a lot of Western European characters. ASCII was no longer just for English. There were ways to kind of pseudo represent that stuff, um, but yeah. And then here's Windows set, very, very similar, I think representing about the same characters, but there are a few other things in there, so the two aren't directly compatible. Okay, I've made a little Arduino program just to show off ASCII. It's going to print all the characters in the ASCII set, including the ones it actually can't print. Right, 128 here. This is for the 7-bit system, by the way, not the 8. Now, 0 through, let's see, 31, that's the first 32. Those are control characters. There's really nothing to show. And then 32 is a space. We go through various other characters, then we get to the numbers, and then some more characters, and then we get to the letters, more characters, lowercase letters, and more characters, and there we go. Pretty simple. But yeah, basically it's just going through 0 to 128. It's doing a print of each number. In the case of this, it's actually um, yeah, it's printing the number, and then it's printing the hex code. It's making it clear that anything below a certain range, well, actually the final one as well, 127. You can't print anything for those because those are control codes. Um, so it's just printing a period. And then we have IBDIC. Now, I'm probably not going to make much use of this, but if we get videos later where we have like IBM mainframe simulators, stuff that I'm just starting to learn right now, this could be important. Basically, it was an update to their older systems. These were all, 6-bit systems, I believe. But yeah, this is what IBM mainframes, some of their peripherals use, even to this day. Converting it to ASCII was more difficult once upon a time, but now it's basically trivial. But then IBM made a lot of products that used ASCII instead of IBDIC, and even some stuff that converted. I don't know much about any of that, so some of that I'm just guessing that when I've read like a sentence or two here or there. You probably are not going to encounter any of this with hobby electronics unless you try to work with vintage IBM mainframes, mini computers, etc. But just to let you know that it exists. All right, I put together a little very brief demonstration of EBIC. Just a few characters really at this point. Oh, let me run this again. So ASCII H would actually be a hex code of C8 in EBIC. E would be C5, etc., etc. So again, really easy to convert, although there's not a direct EBIC support or anything, and it's really only doing for a couple. Actually, no, I think it's actually covering just about everything with this conversion, at least the letters and the space, obviously, too. Now, you might have noticed there's a little bit of a problem with ASCII, but Dick, that was actually addressed with Baudot standard back in the early 20th century, is these things are often built around English. Now, the original Baudot standard also factored in French, but the character difference between the two is pretty minimal. But what happens again with the rest of the languages, and we're just talking about Western European languages initially, well, you need subsets, extensions, and everything. ASCII just supports English as a basic standard. That's why there were extensions to it. Um, you could have subsets, but even then, you're really just talking about the Latin alphabet used with languages from Western and Central Europe. Once you get into Eastern Europe or anything remotely beyond that, you're dealing with completely different alphabets. You're dealing with languages that don't even use alphabets as we understand them. So, what about them? Well, for many years, decades even, it was very common for people, especially professionals, they would learn English just for the purposes of using computers and the more standard ASCII control encoding system. So yeah, so how do you deal with that problem? Well, the ISO, that's the International Organization for Standardization, in the late 80s, they set to finally solve this problem once and for all and come up with something that was both very compatible and could be used universally. And this is called Unicode. It came out in 1991, and the original standard just covered over 7,000 characters, which I put just in quotations because you got to remember 7-bit ASCII was 128. There were no systems even approaching this size at that point. Extended ones, 255 characters maybe, but this was over 7,000. It covered Latin, Greek, Cyrillic, Hebrew, Arabic, I'm going to butcher this, but Davangiri. That's basically an alphabet that's used for a lot of different Indian languages, Chinese, Japanese, Korean. I mean, again, big game changer. You, you might still be learning, wanting to learn English for other reasons for computers, but congratulations, you had a way to display all these characters back and forth with people. Um, so yeah, one character encoding system to rule them all. Now keep in mind this wasn't immediately adapted. Um, Operating systems were kind of slow to adapt it. It wasn't even until Windows 95 that Microsoft supported it, and that was 4 years later. Although I should mention that Windows NT had support for it 2 years prior, but that was the nature of NT, was to have early support for things that eventually got rolled into mainstream Windows. By Windows 98 and 2000 respectively, that's when they had full support. Um, it can be 8 bits, 16, 32 bits. Keep in mind what makes this really work is it does multiple bytes, well, yeah, okay, multiple bytes for each character. It does what it needs to do, basically. Um, so as this is expanded, actually, Unicode's gone through revisions. The most recent revision that I could get data on is Unicode 15. That came out just 4 years ago, and it supports almost 150,000 characters, 161 scripts, 150 different languages, and it even includes scripts for barely spoken written languages, dead languages, near extinct languages. So we're talking Old English, or AKA Anglo-Saxon, Egyptian hieroglyphs, um, if you go back in time, you're going to be covered by Unicode. Now, 16 just came out not too long ago where it's coming out. It's added another 5,000 characters, but I don't know too much about the specifics there. But yeah, everything, desktop, laptop, that kind of thing can support Unicode nowadays. However, there's a little bit of a limitation when we get to hobby electronics. When we're talking about development boards, very limited resources and memory. The thing that is, they can't support the full range of Unicode. They'll usually support ASCII. That's usually not a problem. Some cases they might do UTF-8, but that could be library dependent. But it's not impossible also to make programs to convert. But again, you're dealing with limited processing power memory, keeping in mind that development boards and microcontrollers are getting better and better, faster and faster. So this becomes more of a reality. And of course, when you're dealing with like single board computers, they're full computers. They're going to support whatever you need. Now, just to wrap things up, a CES is computer encoding or character encoding system, just a way to convert a character into a format that a computer can read, process. Technically, a system, a coding system, far predates computers. 17th century, we saw visual semaphores, optical telegraphy. Eventually, we saw Morse code, Baudot codes, Murray, AT, ITA2, teletypes used ITA2, and then teletype interaction with computers. So this is where computers often started when they had to work with teleprinters. Often early systems were specific to companies, sometimes even specific models. We talked about how IBM had their own sets of encoding systems, some of them used to this day. ASCII came along 63, provided finally a universal standard, at least for English, American English. Um, it got added to, and then there were some extended ASCII systems, but I mentioned how they were hardly universal. Some systems like Latin 1 tried to at least add more characters for other Western European languages. Keep in mind, this still locked out most of the world, so they had to have something specific for them, but to communicate between the two. I mentioned how a lot of people learned English just for this reason. But eventually Unicode came along in 91, um, providing over 7,000 characters. 16 provides, I guess I wrote it down here, 16 provides over 140,000 different characters. Dev boards may be limited to just ASCII. You might have a little support for UTF-8, but you're going to need some more serious processing if you really want to use the entire Unicode set. Well, until next time, have a good one.